This is MSJ Chem. In this video, I'll be looking at the reduction of carbonyl compounds. Carbonyl compounds are compounds that contain a carbonyl group, which is a carbon atom that has a double covalent bond to an oxygen atom. Here we have examples of carbonyl compounds. From left to right we have aldehydes, ketones, and carboxylic acids. As we can see, the carbon to oxygen bond is a polar bond. This is caused by the difference in electronegativity between carbon and oxygen. In the carbonyl group, the oxygen atom has a partial negative charge and the carbon atom a partial positive charge. This makes the carbon atom attractive to nucleophiles. So next we look in more detail at the reduction of these compounds. In a previous video, we looked at the oxidation of primary and secondary alcohols. Primary alcohols can be oxidized to form either aldehydes or carboxylic acids, depending on the conditions. Secondary alcohols can be oxidized to form ketones. These reactions can be reversed using a suitable reducing agent. So carboxylic acids can be reduced to form either aldehydes or primary alcohols, and ketones can be reduced to form secondary alcohols. So next, we look at the reducing agents used in more detail. The two reducing agents that we look at in this video are sodium borohydride and lithium aluminium hydride. These reducing agents provide hydride ions that act as nucleophiles. Therefore, these reactions are nucleophilic addition reactions. On the right, we can see part of the mechanism of the reaction. The hydride ion, which is acting as a nucleophile, is attracted to the carbon atom of the carbonyl group. Note, this is not the full mechanism of the reaction. So next, we'll look at the reduction reactions. So we'll start by looking at the reduction of aldehydes. Aldehydes can be reduced to form primary alcohols. This reaction is shown using sodium borohydride as the reducing agent. It's worth noting that lithium aluminium hydride can also be used. The reaction involves heating with the reducing agent and then acidifying. In this example reaction, we have the aldehyde propanal being reduced to form the primary alcohol propan-1-ol. Once again, the conditions are heat with the reducing agent and then acidify. Next, we have the reduction of ketones. So ketones can be reduced to form secondary alcohols. The reducing agent can be either sodium borohydride or lithium aluminium hydride. In this example reaction, we have a ketone, which is propanone, being reduced to form propan-2-ol, which is a secondary alcohol. The conditions are heat with a reducing agent and then acidify. And finally, we have the reduction of carboxylic acids. So carboxylic acids can be reduced to form primary alcohols. Note that carboxylic acids can also be reduced to form aldehydes. The reducing agent used in the reaction is lithium aluminium hydride. This reducing agent is used because sodium borohydride is not a strong enough reducing agent. In this example reaction, we have the carboxylic acid, which is propanoic acid, being reduced to form the primary alcohol, which is propan-1-ol. The conditions of the reaction are react with a reducing agent and then acidify. Let's end the video with a summary. Aldehydes can be reduced to primary alcohols. The reducing agent can either be sodium borohydride or lithium aluminium hydride. Ketones can be reduced to secondary alcohols. The reducing agent can either be sodium borohydride or lithium aluminium hydride. And carboxylic acids can be reduced to form either aldehydes or primary alcohols. The reducing agent is lithium aluminium hydride only. This is because sodium borohydride is not a strong enough reducing agent to reduce carboxylic acids.